There are two broad categories of transformations that chemists need to do in organic synthesis. One is to make functional groups. The other is to make carbon-carbon bonds. It's the carbon-carbon bond forming reactions that lets you make big molecules from smaller ones. Smaller molecules are the ones that are readily available, primarily from petroleum. So a key task then is to assemble small molecules into larger ones, making carbon-carbon bonds. The Grignard reaction is especially useful because it lets you do both of these things. You make a carbon-carbon bond while you're making a very useful functional group, alcohols. Take a look. This is an organic compound that has a metal bond. These organometallic compounds can be covalent, and in a case like this, it is pretty much covalent. These guys are soluble in ether solvents, and the reactions are run in ether solvents. Because the reagents are extremely sensitive to reaction with the proton on hydroxyl groups, water, amines, it's essential that these ether solvents be anhydrous. And now that we've said all that, we'll probably skip the solvent stuff when we're talking about reactions. This is covalent. It's soluble in diethyl ether, for instance. But in terms of reactivity, we can think of this as if it were an anion. And the carbonyl group has a polarized double bond, so there's a partial positive charge on that carbon. The combination of something that behaves as if it were an anion with a pair of electrons to share, together with a carbonyl group that has a partial positive charge on carbon, gives rise to this reaction. You picture that pair of electrons forming a bond with carbon as this pair of electrons moves to oxygen. This is really ionic at this point. A negative charge on oxygen and a positive charge. Making the alcohol, then it's simply left to treat this with water. Which puts a proton on that oxygen in place of the magnesium. And here's the new carbon-carbon bond we've made. It's bonding this alkyl group from the Grignard reagent to the carbon of the carbonyl group, while the carbonyl group itself becomes a hydroxyl group. And whatever was here will be attached here. And whatever's here will be attached here. So you see, by varying the structure of the Grignard reagent, this alkyl group, and varying the structure of the carbonyl compound, you can get a wide variety of compounds where we've made a carbon-carbon bond and a hydroxyl group simultaneously. So it's an extremely useful reaction. It wouldn't be useful if we couldn't make the Grignard reagents fairly easily, but in fact we can. These Grignard reagents are made simply by treating an alkyl halide with magnesium. Again, in ether solvents, must be anhydrous. A variety of things can be here, here, and here. This often is bromide, but may be iodide. So there's tons of power in this reaction. In terms of the carbonyl compounds that we're going to talk about, there are three functional groups specifically. This guy we'll think of as being an aldehyde. Recall that formaldehyde is a special example, so we put that as an ketones work. So you can have two alkyl groups rather than just one. And we're going to look at a special case. There are others, but the special case we're going to look at is esters. And I'm going to put the prime there, and you'll see why. Looking specifically at these reactions, when a Grignard reagent reacts with formaldehyde, with water as a second step, the product, here's our new carbon-carbon bond, is a primary alcohol. When a Grignard reagent reacts with other aldehydes, the product is a secondary alcohol. When the carbonyl compound is a ketone, are you ahead of me here? The product is a tertiary alcohol. And just for fun, we'll look at the special case. The product, when the Grignard reagent reacts with an ester, is a tertiary alcohol. But it's a special tertiary alcohol. Check this out. This alkyl group from the Grignard reagent is this alkyl group. In the reaction with other aldehydes, let's say, here it is. In the reaction with ketones, let's say, well, here it is. And in the reaction with esters, let's say, well, here it is twice. So in these other cases, we've added the alkyl group once, and in the case of reaction with esters, this is twice. So these alkyl groups must be the same thing in this tertiary alcohol. So, bottom line, synthesis of alcohols using the Grignard reaction. We can make primary alcohols, secondary alcohols, tertiary alcohols, and you can make tertiary alcohols where two of the alkyl groups are the same thing. Very, very powerful. Let's take a look at how we could use the Grignard reaction to plan the synthesis of alcohols. Recall when we plan the synthesis of alcohols, we think backwards. We look at the target and ask ourselves what this could come from. And when we look at a primary alcohol and think about the use of a Grignard reaction to make it, this structural group tells us we should use an R group attached to a magnesium halide, together with formaldehyde. If we look at a secondary alcohol, R group here, different R group here. When we're plotting that, we could envision either this alkyl group or this alkyl group coming from the Grignard reagent. So there are two possibilities. And notice I'm writing these atoms in exactly the same places in both molecules, precursor and target, so I don't get confused about structure. And the second possibility would be this Grignard reagent plus this carbonyl compound. So both of these work to make a secondary alcohol, two different combinations that we should consider. And are you ahead of me here? When we have a tertiary alcohol, we could have this Grignard reagent reacting, or this Grignard reagent reacting, or this Grignard reagent reacting. And here, the carbonyl compound we need looks like this. And the carbonyl compound we need looks like this. And the carbonyl compound we need looks like this. So primary alcohols, one option. Secondary alcohols, two options. Tertiary alcohols, three options. Which should you do when there's more than one option? Well, sometimes it doesn't matter. And other times it does matter. Sometimes you can only get your hands on one alkyl halide or a different alkyl halide, or one aldehyde or a ketone or another. So sometimes what's available will determine which of the options you choose. And other times it will simply be your choice. There will be more than one option and you can choose the ones you prefer. The Grignard synthesis of alcohols, an extremely powerful way to make alcohols while making a bigger molecule from two smaller molecules.